So we want to evaluate the definite integral from 3 to 3 of f of x dx. And we're given the graph of f of x and of y equals f of x and the area between f of x and the x-axis over different intervals. Well, when you look at this, you actually don't even have to look at this graph over here, because in general, if I have the definite integral of any function, f of x dx, from, let's say, a to the same value, from one value to the same value, this is always going to be equal to 0. We're going from 3 to 3. We could be going from negative pi to negative pi. It's always going to be 0. One way to think about it, we're starting and stopping here at 3, so we're not capturing any area. Let's do another one. So here, we want to find the definite integral from 7 to 4 of f of x dx. So we want to go from 7 to 4. So we want to go from 7 to 4. Now you might be tempted to say, okay, well look, the area between f of x and x is 2, so maybe this thing is 2. But the key realization is this area only applies when you have the lower bound as the lower bound and the higher value as the higher bound. So the integral from 4 to 7 of f of x dx, this thing is equal to 2. This thing is depicting that area right over there. So what about this, where we've switched it? Instead of going from 4 to 7, we're going from 7 to 4. Well, the key realization is if you switch the bounds, and this is a key definite integral property, that's going to give you the negative value. So this is going to be equal to the negative of the integral from 4 to 7 of f of x dx. And so this is going to be negative, and we just figured out the integral from 4 to 7 of f of x dx. Well, now that is this area. F of x is above the x-axis. It's a positive area. So it is going to be, so this thing right over here is going to evaluate to positive 2, but we have that negative out front, so our original expression would evaluate to negative 2.